The next section in Unit 2 talks about decision making based on probabilities. We're going to do 2 or 3 different scenarios. The first scenario talks about video games. In this particular video game, you have to pass through a couple gates in order to move on to the next level. The first gate is open 20% of the time. The second gate is open 30% of the time, and they're both open 10% of the time. So you're going to have to model this probability, or the students are going to have to model this probability and answer some questions based on these numbers and these numbers alone. Now, we've gone through 3 different probability models, and you can do any model. In this case, I think that it's best to use a Venn diagram because of this piece of information. It allows you that center overlapping section between the 2 circles. It gives you that percentage, and then everything else is a very simple subtraction from 100% or from the numbers they give you. So go ahead and making the Venn diagram. Always incorporate the rectangle around the circles to identify the time when something applies to neither option. So gate 1 is open, gate 2 is open. They're both open 10% of the time. Now in this case, the percentages should all add up to 100. Gate 1 is open 20% of the time, so circle 1 should add up to 20%. That means gate 1 is open by itself 10% of the time. 10 plus 10 is 20. Gate 2 is open 30% of the time, which means by itself it's open 20% of the time. And if you notice in here we have 40%, which means 60% of the time they're both closed. And that allows you to get the probabilities and analyze calculating the probabilities based on these numbers, and especially some of these numbers that aren't necessarily given to you in this information. Another challenge in this game is to hit a target, and if you hit that target in one try, you get an opportunity for a second try to get a bonus shield as long as you hit that target both times in a single try. The probability that we need to have here is 60% of the time the target is hit in one try. 60% of the time the target is hit in one try. So if my challenge is to hit that target in one try and then try to get the bonus shield, what's the probabilities associated with that? We could probably do another Venn diagram, but in this case I like to use a tree diagram, because here we have the first attempt, and 60% of the time we will hit the target, 40% of the time we will miss the target. Now, the rules state if you hit it the first time, you get an opportunity for a second try for the bonus shield. So only going after the first hit will you have an opportunity for a second. 60% of the time, 40% of the time. The probabilities don't change just because you had a first try. 60% of the time, the information here is still given. 60% of the time, you hit the target in one try. However, what's the probability of getting the bonus shield? The probability of 2 hits is going to be 60% times 60%, which is 36%. So here we can calculate the compound events of 2 attempts on that target. The next scenario in decision making based on probabilities is this type of chart where you have males and females, type of vehicle they have, and whether or not they've been in an accident. If you notice here, this chart has 3 categories: male versus female, accident versus not being in an accident, and then the type of vehicle, car versus a motorcycle. So I suggest doing a Venn diagram. And here, this circle deals with gender, so male. Anything outside of that circle is female. We have car inside this second circle. That means everything outside that circle is motorcycle. And then right here we have if they've been in an accident. That means everything outside of that circle means they have not been in an accident. And so what you need to be able to do is identify each section of this Venn diagram in terms of all 3 categories. You have to be able to either label them or describe them. I like to start off my Venn diagrams discussion with my students and tell them to write the actual labels for each section depending on however many circles there are. That way they can understand what information they're actually looking for. I like to start also from the center and work your way out. So here we have males that have a car that have been in an accident. That's 40. It's given to us right here in the chart. Right here we have males that have a car that have not been in an accident. Well, if you notice, there's 150 males that have a car and only 40 of those have been in an accident. So that means there's 110 that have not been in an accident. Right here we have males in a motorcycle that have been in an accident because it's not inside of this circle that says car. So this is motorcycle, male, and accident. Male, accident, motorcycle, that is 6. This section right here is males that have a motorcycle that have not been in an accident. Males with a motorcycle is 23. 6 of those have been in an accident, which means there's 17. Now we're looking at the females because the male circle has 4 sections and all sections have been filled in. So here we want to look at females with a car that have been in an accident. That's this section right here. Females with a car that have been in an accident is 15. This section is females with a car not in an accident. Well, females with a car not in an accident, subtract these two and you get 210. This right here is females with a motorcycle that have been in an accident. Females with a motorcycle that have been in an accident is 4. And then outside, remember this rectangle identifies the space around the Venn diagram where none of the things in the side of the circles has happened. So that means females with a motorcycle not in an accident. So females with a motorcycle not in an accident is 6. And now you have calculated all the different events that could have happened between these 3 categories. And that is decision making based on probabilities.